Alright, algebra, let's do this test review. Here we've got this guy Jarrett who made somebody's favorite mistake by simplifying this expression, and I think it doesn't take too long to see that his mistake is that he didn't reduce or simplify the root 18. Root 25 is 5, root 144 is 12, 5 times 12 is 60, and then this negative is hanging out front, so it's negative 60. What he should have done is broken down the 18, the 2 and a 9, and then if you need to, you break it down to 3 and a 3, and you see your double, and you know you're going to multiply negative 60 by 3 for negative 180 root 2 should be the final answer there. Here, half powers are square roots, which means that the simplest way to rewrite this is 5/9. However, since I know the way it's presented on the test, you need to know that this is equivalent to root 25 over root 81, which are both equivalent to big root over 25 and 81. These 3 or 4 formulations are exactly the same. It just depends on how you want to express your answers or your material or your numbers. Half powers are square roots. Here, after the warm-up and the quiz today, this should be pretty easy. The first term is 75, and then we're just going to multiply by 3/4 repeatedly until we get to the fourth term. So 75 times 0.75. The second term is 56.25 times 0.75 or 3/4, 42.1875, and then multiply by 3/4 again, and you get 31.640625, and you it turns out that that is equivalent to the fraction 2025 over 64, or 31 and 41/64, or the decimal number. So who knows exactly how you'll see it on the test or exactly what it'll look like, but all 3 of those answers are equivalent and perfectly acceptable. Improper, mixed number, and fraction. I'm partial to improper, but I see the appeal of these 2. I don't like 4, so we're not going to do it. It's not specific enough, though there is something similar to that on the test. Sarah won the lottery, and she received a check for 10 grand, so that's our initial value. And then she deposited the money in her account that earns 4.5 interest, 4.5%. So that's going to be times 1 plus 0.045. So it's 4.5% greater than 1 because we're earning and we're growing our money. So it should be 1.045 for the value of b, or the growth rate, raised to the x power, and that's all they want is the function. They don't need a value. Here, the 5 and the 6 aren't going to simplify, but the 4/9 and the 1/9 are going to subtract to become 3/9 or 1/3. So that's 5 and x to the 3rd power. And then the 4 minus 8 on the exponents for the y is going to give us negative 4. So that's going to be y to the 4th on bottom. And then the negative 3 on the z is just going to bring the z down to the denominator spot. So that's z to the 3rd power. And that should be it. 5x to the 1/3 divided by y to the 4th is z to the 3rd. And then the 6 should be in front here too. And that looks good. When you look at this iPhone problem, it should be pretty obvious that we're losing half the value every year. So write the function that represents the data. Well, we've got our starting amount, $800. And then we're going to multiply that by 1/2. And then we're going to raise that to some power, probably the x power, or the t power, or the n power. It doesn't matter, it's a variable. Okay, here we've got Honor and all of her boyfriends. This value right here, that's the number of boyfriends she has in the very beginning. So she starts with 3 boyfriends, which makes this statement false. And then this is the growth rate. So she's increasing the number of boyfriends she has by 20% each year. She's 20% over 1, or bigger than 1, so we're growing by 20%. The function indicates that the number of boyfriend is reducing. Absolutely not. That is completely false. So the number of boyfriends Honor has is definitely not reducing because our value of b is bigger than 1. It's 20% bigger than 1. The rate of increase of her boyfriends is 20%. Yes, that is true. And then we did this one in class, but I'll go ahead and rewrite. We've got all real numbers for the domain. Our range is going to be not x, but f of x has got to be greater than 10, or greater than -10, but not equal to, because our asymptote is a horizontal line there at y equals -10, and the function is going to approach -10, but it'll never get there. The y-intercept is pointed out right there, 0, -9. That should be very straightforward. And then the asymptote is the horizontal line at y equals -10. And remember, if it intersects the y-axis, then it is horizontal. If it intersects the x-axis, then it's vertical. You can know the equation. It intersects the y-axis, so the equation is y equals. If it's vertical and it intersects the x-axis, then the equation is x equals. And it's a callback to earlier in the year. And then this vocabulary, this language is pretty good. As x approaches -infinity, so as I go back on the x-axis to the left, what's happening to y? It's approaching 20, but then it's shooting past 20 up to positive infinity. So this is false. And y approaches positive infinity would be a true statement. And as x approaches positive infinity, so as we go this direction on the x-axis, what is happening to y? Well, y is decreasing toward -10, but it's never going to get there. So this is false. Y approaches -10. There you go. Hope that helps. I'll see you tomorrow.